please have a look the course content, and you will see here the statistics. We should start from the descriptive statistics, right? So descriptive basically the base part, and then we will go for the pre-processing part. Okay, that is the data pre-processing sometime we say, and next we will go for, not in this course or not in this lesson, maybe overall I'm talking about right now. And next I will go for the transformation. Exactly, so transformation is also important. We will see how we can do, but maybe it is not for the few minutes, it will take whole lecture. Okay, so and after then we will also see it is most important for the graphical things like visualization, how you will show your data, right? How you will project your data to the audience, or maybe to your management. Basically, you know, if you are working in a company, example, you should show the data in a graphical way, and you should show how your data is relevant. In that case, it is most important for a graphical visualization. So in data science, in a data analysis, we have, in a machine learning and even in a statistics, we have a lot of graphs, and we will try to study one by one, and you will also make by your hand on your system. Okay, that is the visualization. Okay, next most important is a test. That is the statistical test. That is the name is the parametric test. Can you see here? So can you see these are the, it is actually big subject, but I will try to cover a lot of things under this parametric test. Okay, here we have a lot of statistical test. I will try to include most popular which is using, maybe you will see. Okay, so I will also use these tests for analysis the data. Okay, and after then we will go for the non-parametric test. Maybe I will explain you later on what, when I will start the lesson actually, then I will tell you what is the actual difference between two things. Okay, why we use a parametric and why we use a non-parametric. Okay, this is there will be a lot of rules we will learn. Okay, and after then I also decided to put a regression problem here. Mostly nowadays we have a regression problems in our real life. I will, we will have a specific lesson on it. So regression I will discuss. Basically, this is a starting of a machine learning, right? That is a regression. Okay, regress. You have to something regress, how it is impacting something, right? So that is a regression. And in a regression, we have a lot of algorithms. Okay, but we have not enough time to discuss. But I will try to put the basic one. Like a linear, logistic, and a lot of regression, we have multilinear regression we have. I will try to cover up in this course. Okay, and after that I also included the association part. You know, association is, what is the association? Association is a linkage. Linkage mean to say the connectivity, correlation, if you remember. So you know, we have to think whether which data is a correlated or not. If there is something correlation, it is a good idea to use. If there is no correlation, uh, we can use, but in other aspects, but there is no meaning for that data. You know, if there is some connectivity, it is a good, you can show there is something linkage, but you have to prove. You have to prove by the facts, by the theory, and by your equations. That is the association. Okay. And next topic, reduction of the dimensions. Dimension is nothing, it is just like you know, the feature basically, we should say, right? So dimension reduction example, practically I'm telling you example, we have a 100 features. In 100 features, which is relevant to you, that's it. Maybe 20 features can be good for me, or maybe 40 feature can be good for me out of 100. So I want to go for, and also I have to justify why these features are good for me. If you have a fact, then you should go, otherwise no, right? That is the reduction. Mostly most popular in a machine learning, we use it. And most, there are a lot of algorithm you can see, but mostly popular, I will try to discuss it here. uh, the principal component analysis, it is a mathematically term, but we will do practically here with the tool, and whatever the output will be there, you will see and how to use it. Okay, that is the PCA. Okay, so and after that, machine learning, more algorithm are there. I will try to cover up as much as which is in the tool later on, and also I will tell you what is the basic of the machine learning and how we can use it. But until or unless we have not the basic knowledge, example descriptive up to here, test and regression association, there is no use for using go for the machine learning. So in the last 2 or 3 lessons, maybe I will cover up the machine learning, some algorithms in the IBM SPSS. Okay. And also, I also try to put this cluster analysis as well as I will also try to discuss if we will have enough time. Okay. What is the cluster actually? Actually, this is a machine learning part, but I put as a separate entity because it is just like a classification problem, and cluster is most important to know about it. What is the cluster? Example, we have 1,000 people, right? So on which behalf we have to be, grouping them. That is a cluster. Make a cluster for this, like, okay, so that is a cluster, and we will see which algorithm, hierarchical cluster algorithms are there in IBM SPSS. It is there, and as compared to the Python, this is a very good tool. If you want to go to design or draw very good graphs, with a very resolution images, it is very nice as compared to the Python. In Python, yes, we can draw, but in my experience, it is good to use, right? So visualization is very nice here in this tool. Okay, so I'm sure you can make a good practice here, and in future it can help you not in the company as well as in your data scientist career. If you want to go in this field, you can easily join any field in a data science. And these are the basically for data analyst, or maybe data engineer. You can also say data engineer. So, and after then, if you understand the algorithm or something, you can go for the data analyst. Basically, it means you can also write your own algorithm. Okay, so basically this is not in the depth, just for the basic of the statistics and machine learning course. And I think it will give you 2 credits, right? Or 5 credits, 2 credits. But 2 credits is not easy to get. You have to work hard. Okay. So now I think everything is clear to you guys or not, for the course starting or whatever, right? So before starting the descriptive statics, because today I will not go for this one, maybe I will speak little bit 2 or 3 slides. But before that, I would like to know about the program, because you need the tool. You need the IBM is here. You please type IBM. Maybe it will show here. Will give the solutions. Is it okay, everyone? I think you can see the IBM is ready in my system like that. Can you see? In this system, we will put the data and we will see how we can analyze the different techniques. IBM, you installed? Oh, nice, great. Please go. Yes, no problem. Please go next, next, next. Okay, because okay, so you can use the next. Okay, if you have your license, you can put it here. But now you will install without the license, and when you will use the VPN connected here, automatically it will authorized by the VPN. Yes, next, next. Oh my God, please, maybe you can go back and try without the license. It is for if you purchased. Okay. Yes, yes, finish. We check it. No, you please finish it. It is installed, and when the VPN will be installed, automatically it will check. No need to give any file. Okay, I use the same like you before. Okay. So, dear students, is it clear up to you what you need for a next week practice actual, right? VPN and SPSS. So be ready with it, and it is your first uh, you know assignment. No need to upload anything. I will not check any on the canvas. I will check here to your laptop that, sir, it is running, VPN is running and SPSS is running. That's it. After 5 or 10 minutes, I will start directly here. Is it clear, everyone? Right? Okay, so now let's start. I will not waste the more time. 20 minutes or 30 minutes, I go for my lesson. Okay. Okay, so please carefully listen what I'm going to say and understand the concept actually. Most important, right? So first of all, in a descriptive statics, you will see example analysis here, descriptive statics, right? You will see actually there are a lot of things, but actually these are, it is not hard and fast, right? Example, ratio, pp plots, okay, maybe I will clear the plots, but these are not hard and fast because IBM put these one. But in a statics and the basic term descriptive is, suppose I click, so I need some data, but I didn't pick it up right now. So descriptive things will be like that. Okay, but we will do in practice next week, not now. But now we have to understand the concept as the theory point of view. Okay, so next week I will take some data and show you. Okay, so in descriptive statistics, we need to understand the population. And population, you know very well what is the population. Population is just like uh, the collection of the data actually, basically, right? Which we want to focus for our research purpose. Suppose in Hungary we have a million of peoples are here. You want to do the research, so it is not feasible. You will go to all one people one by one and do your research and ask something. Just think, it is quite awkward. So what you will do, you have to be get some samples, right? You have to select some data from overall the population. Okay, so that is called the data sampling, selecting the samples, right? So next is the mean. I will discuss here one by one, right? So next is the mean. What is mean? Mean is the average. Median, which is the mid value, right? Mode, what is the mode? Frequently data, right? How many times? Example. Variance, what is the variance? Like a change. So because these are the small concepts, but it is most basic for a machine learning. If maybe future you will go for the spot vector machine, neural network, so it is most important because we should start from the scratch data up to that, because all the algorithm use these concepts. Base, percentage, very easy, deviation, that is called the standard deviation, that is the dispersion. Sometimes we say dispersion, how much the value is deviate from our mean value, the average value, right? In practically there should not be high deviation, better to be a less deviation. Okay, so if there is a high deviation, so data is it is not good. Sometime you need a data, there is a standard deviation should be less. Okay, so these are the basically descriptive statics. There can be more and more, right? Okay, so let's go for now. Why this descriptive statics, which is important? So first of all, to understand the huge raw data. Huge example, we have a thousands of people, and you want to know the age or whatever age of the people. In that case, it is very difficult. You cannot do one by one. So better to use the descriptive statics. You have to summarize that out of 1,000 people, 500 people whose age is 50 years. Example, 300 people whose age is example 30 years. Just think. And rest of the people like a 200, they are adult or maybe 20 or 20 years. So you can describe your data in that case. So that's why we use a descriptive to understand the huge raw data. Okay, to get a representative value of the whole data, the value 1 which can representative your whole data. Okay, so example, you have a 1000 people once again, and you want to show with a small value. Example, you get a 100 people to test your data. In 100 people, if you can justify that uh, there are some relation or something, it depends upon your research problem. Maybe I will go next uh, some lessons I will show you practically, so you will understand on that case. So the 100 people value should be represent the 1000 people, right? Basically representative value, one value should represent all. Okay, to compare between the two or more, here I put some new things, variables or categories, something. So please remember, these are not like a different, it are the sometime in data field we say the variable, sometimes we say the feature, sometimes we say the attributes. Keep in mind same things, right? So we also use the descriptive statics for compare the categories, to compare the variables. Example, I want to give again your example here in class. So suppose we have two girl student and others are male student. We want to see who got a good score in the exam. Just think. So I can compare maybe the girls or maybe the boys. Just think. So this is just like a I'm comparing the category. Okay. So this is the idea. Okay. Now there are element of a population. Example, in population there is important term is elements. Element is most important. Element mean to say which can represent your population as a characteristics. Okay, example, in my population we have only two category. One category, one class, that is a gender, and gender has a two category subclass, that is a male or female in this example, right? If I will say age, you can also divide a age in a different category, like adult less than 20, about 21, and age like above 50. So think about it. So this is basically the elements of the population. Okay, again, example, I put it here in the slide, comparing the marks of two group of a student of a same subject. Okay, I want to check, I have supposed two group of computer system. I want to check which group is more intelligent or maybe more score data, score examination, good examination. I can compare easily. Okay, I will take the data on a two series and I can put my technique or test and I can prove this is good. But you should have some proof. Without a proof, you cannot say this is good or not, right? Okay, next I also put the example comparing the marks of boys and girls in a one class. That is the category comparison. I told you previously, I think the same example I given again here. I want to check who is more intelligent, girls or boys. Okay, so this type of the research questions, or maybe your manager in a company, they can ask. So in a company, we will have not a small data like 100, 1000. There can be a million of terabyte data you should have. So you should have a long memory, long GPU, right? So, but we should know the basics that how to use it. This concept will be applicable everywhere. Okay. Okay, so this is the basically we need descriptive statics. Okay, now descriptive statics, what is this actually? You can find a definition on the internet, a lot of things, different authors say, but I will say it is a measurement which describe our data. It will describe two things, describe the measure of a central tendency, okay, and describe the measure of dispersion. So measurement of a central tendency, what are these? Mean, mode, median, example these. And measurement of dispersion is a standard deviation. Basically, these are the two basic facts which we work under the descriptive statics. right? Next class, we will calculate all the things in a tool, right? By taking the example of a data. So measurement of a central tendency. In an interview, they can ask you, what are the measurement of central tendency? You will say, sir, mean, median, mode. So you can say, so it is a basic basically. So mean, this is a average. Sum of the observation divided by n, sigma x by n, right? There will be some value and you can divide and you can find the mean value. It doesn't matter. It can be sometime if the value is floating point number, it can be point. It can be give you the floating point numbers, and later on you can use round off or round up function. Okay, it's not a problem. So this is basically a measurement of a central tendency. This is a mean value. Have a look here. Number 4, don't give a true mean. So we go for a median. Example, why we should not use the mean? Why, in which case we should go for the median? See here. In this case, number 4, 84 is also here. Again, 84 is also here. It is a repetitive entity. So we should consider mean only then when we have not repetition in that case. It is good, but mostly statisticians and data engineer use it. Not a problem. But if you want to get a good results, accurate result, you should avoid the repetition type of a value in that case. See example, what is the mean value? Is it comes up here 82. Just think, and you can see here the same data we have 84, 76, 75, 84, and 91, and see one new value is added 4. Now the value, see your mean, where your mean is going up. See the difference in between 82 and 69. In that case, what you will use? Median. So small things please keep in the mind. We should, when we should use our mean, when we should use on the median. Okay. So median is the, as you told, it is a middle value of the observations, which will reflect 50% left, 50% right. You see, this is the median value. That's why in that case, you should pick up that value to represent your data, right? Okay. So I told you in the previous slide here, representative value. Mean can be the representative value. Median can be the representative. Okay. So okay, median of it is a middle value of observation. So how we can do? Divide the whole observation in a 2 equal part and apply when the data is skewed. I will talk about the skewness very soon, maybe now or maybe next week it will come. It is important to know about the data property skewness. Okay. So how to estimate, how we can calculate? So first of all, we have to put the data in a ascending order, 1, 2, 3, 4, if you want to calculate the median. So get out the median value, right? In case you have a 2 middle value, you have to again apply the mean. In this case example 1, 2, 3, 4, what is the median? 3. If we have this value, what should be the what are the two? We have a 2 median value, 3 and 4. Now you should not consider the 2 median value. In that case, you have to do mean. 3 plus 4 divided by 2, 3.5, like that. Okay, which basically SPSS also use these techniques. But you will also apply the data, you will apply the test, you will see the result directly on your editor. Okay, so it is also the measurement of a central tendency. Okay, now we talk about the mode. What is mode? Mode a value which comes maximum number of time in our data observations. So it can be unimodal and bimodal. If lack of the value, if there is a no repetition, it means to say no mode. There is no chance of the mode because there is no repetition. So see in this case, 1, 2, 2, 3, 4, 2. It means to say what is the mode? 2, unimodal. Okay, and here you will see again bimodal, 2, 2 and 2 again, right? So here mode 1 and 2, right? So in this last case, you will see there is no repetition. It meant to say lack of mode. In that case, there should not be. You can apply mean value, you can apply the mean function, you can apply the other functions. So it is very simple. It is a basic one you should understand. And within a 5 minutes, you can take a data and you will apply, you will see all the values easily in SPSS. Okay, so now important to understand here again, when it is a suitable of measurement of a central tendency, in which criteria, in which issue. So I put a small table here. Okay, it applicable, it depends type of a variable, which is your variable actually. So I will discuss, maybe the test will come, you will see, I will tell you what is this variable, like categorical variable, ordered variable, so there are some things I will discuss. So type of the data, which type of your data here, right? Like a normal or abnormal. Measurement scale, which scale you have used. So basically depend upon these, we should know where you will apply the mean, where you should apply the median, and where you should apply the mode. Can you see the measure of central tendency, type of variable, type of data, scale of measurement, and example here. I give the real life example here, you can find the blue one. So example, if your data, if your mean is example, if type of variable is a numerical continuous variable, example here, height of a student. It is a continuous value, right? It's not like a discrete. So continuous value, height of a student, outside temperature, money in your pocket. Money in the pocket, it's also a good idea. So continuous value, just think. So in real life, we have a lot of things. You can understand this is the continuous value, right? Okay. Again, in that case, when you applied the mean value, this condition, see, right? And type of a data, symmetry data, I will discuss maybe next, uh, skewed, symmetry or asymmetry. Okay, when the topics comes, I will tell you, and then you will remember this slide when you should apply. Okay, so when that your data is symmetry, you should apply the mean. If your data is skewed, okay, you should apply the median. If mutually exclusive category, in that case, mode. Okay, so please read this one. It is no, it is most important table which is understand to go further. Example, marks of a students. Yes, please. Mean, it depends upon the data actually. If your data is symmetry, you should use the mean. But in the last slide, I show you mean value here. If your data is like that, where is less repetition, right? But it's not a hard and fast. You can apply, but you should check. Uh, if you adding the value like 4 here, you see how the mean goes. You know. So in that case, you should not apply the mean. I have just given the example. You have to check by the tool, or you have to check the value. If you're adding a small value, so practically it is say outlier, extreme case in SPSS. It is the term. It will come, and practically I will tell you how you can detect a outlier, right? So here you will see in my case here. Can you see these all values are nearby? Okay, so only this is like a odd value, because it's very small. So in this case, SPSS will tell you that this is the outlier, right? You have to get out this value from your data and take out and do experiment again, you will get a true results, right? So I tell you in which case you have to apply. This table will tell you if you have a numerical value, you can use apply the mean value. If you have a numerical skew data, I will also talk about the skewness later on, but till try to see this table. Okay, if you have a categorical variable like gender or maybe age example, and maybe classes, bachelor or masters, the thing, in that case, you should go for the mode, right? Example, how many girls are repeating, in that case, you can write a mode, right? So that is the basically mode. So, and here, yeah, it was written here, gender and region, right? So please have a look. And also please see, I put a graph here. When mean, median and mode equal, then your data is a normally distributed. This is a normal distribution. Can you see this angle? So practically it is a bell-shaped curve. If it can be left, it can be right. It is a left skewed or right skewed. That is skewness, but I will talk later on. Okay. So please think about it. Your data should be normal, distributed for applying the statistical test. And I will tell you later on when the topics comes, we will see which test is good for this, which test is good for this, right? So this is a basically idea. Is it clear? Okay, so measure of dispersion. Dispersion is a standard deviation. How the value is deviating from the mean average. How my data is dispersed across the data set actually, which cannot make out the measure of the central tendency. We should not forget it. It is also the good idea to use. We also usually see the standard deviation. Your data is highly deviated or less deviated. Basically, it should be less deviated, right? So, so we can have different set of observation, but the same mean, right? Example, mean of here. Can you see? Mean of these terms is if you calculate by the calculator or by a tool, so it will show you the 6. The mean of these is the same. We can have a different set of observation, but the same mean, right? In that case, the term come for the standard deviation, right? For this type of a data, we need the standard deviation. Okay, but usually we don't consider this data in the analysis. We should need this type of a data, right? Okay, so type, range, standard deviation, interquartile range. In that case, you should go for these 3 statistics again. Okay. Okay, so let's see. There is a range. So what is the range? Is the name show? It is a difference between the maximum and minimum value. So see this data. What is the maximum value? 56. Minimum value 30. Difference is 26. This is a range. Standard deviation will tell us how individual observation is far from the mean value. I put in the definition. The statistical formula is here. This is the symbol of a standard deviation, mu, and this is the mean value, and this is the population standard deviation, and this is the size of the population, and this is the value in a data set. Okay, and if I minus the mean from this and do the square root, this is a standard deviation. If I will take the value here, the square, that is called the variance. Square root of variance is the standard deviation, right? Can you see? The variance is also. So if you go in the detail, so we can use the variance. Okay, so see the variance. If you do the square here, it will be cancel each other. It's a mathematical formula, you will see. And standard deviation is a square root of a variance. Square root of a variance is called the standard deviation. Okay, so it is the, again, in which case you have to use? In that case, right? If you have this, no need to go. Only simple we have the mean. That's it. But usually in our life, in our problem, we will have this type of a data. Okay. Because some students can have a low marks, some students have a high marks, some students have a medium marks. We have to understand. And you can take the student who has, suppose we have a exam of 100 marks. So the student who have a zero score, in that case, that score can disturb our analysis. You have to take that zero from your, just I'm giving the example, maybe 1 or 2 or 3, and all the students have a 50, 60, 70, 80, 90. In that case, you have to skip out that lower mark students for analysis purpose. Otherwise, that will disturb your results. Yes, obviously you can tell this is the only student who has a less score. But if you go for the another techniques, it's not recommendable. Think. Okay, so have a look. Okay, next is the I discussed with the range, and next is the interquartile range. That is the IQR. Basically, separate between the first and third quartile. Can you see here? Please have a look on this diagram. First quartile and second quartile and third quartile. Practically, I should say in between these two quartile show our median value. So 20, this is 100% data, and 50% is showing the median value because it is in the mid value, right? So this is complete the IQR. You can see here. So middle 50% is a IQR, right? Which spread between here, it is showing like a blue color, right? So this is your interquartile range in this example only, but in your data it can be left or right somewhere. You have to check where is your data is more spread or less spread, right? So see, Q1 is a portion, this is a portion where 25% observation below, right? It can be here in your data. You will check if you have your own data in SPSS. Okay, so Q3, 75% data below it, 20% above it. Here this is showing this range. Okay, so basically this is a interquartile range. Okay, so now next I can also speak about the population, but I will start this topic for the next. I think we have 6 or 7 slides, maybe population. I can discuss about the population. Okay, so okay, so let's, I think I try to discuss the population more here. So you know what is the population? Population is the basically the group or the our target value where we want to draw our research or conclusion somewhere, right? So suppose I want to say, please make a research on this faculty informatics students, and you should know, sir, we have a 1,000 students in fact informatics, but you cannot collect the in 1,000 student data. You have to represent, you can collect maybe 200, 300, 400 samples, and you can do your research and represent that 1,000 students. But that 300 student data should be relevant. They should have some properties you have to prove. Okay, so we will see later on. I will tell you which is the good property which show you. Okay, so that is the population. Example 1,000 students in informatics. Just think, I'll give you an example. Next is the here, and next is the sample, the specific group that you will collect the data from. It can be the specific group. You can take the sample from here. Okay, it can be 100, it can be 200, it can be 50, it depends. But usually we say it should be n ratio 1. Example, you depends upon the variable or feature. If you have a 10 variable, 10 feature, it should be multiplied by 10, right? So it should be 100 sample you have. It is a standardized set. In statistics, we say if you have a 20 feature, multiply by 10, you needed 200 samples. If you have a 30 feature, multiply by 10, 300 samples, right? This is a formula for a good results, but you can collect as you want, but this is a definition or standard guidelines by statisticians who can who can set, right? And size of a sample, obviously it is less, it is a big, right? And there are some elements of population like a male or female. Here you can see, I don't know which is the red or male or female. Just think about it. Is a male or female? This is randomly right? So these are the elements. And again, the population. Another example. Take a bell paper here, bell shaped papers here. Can you see the different color papers here? So population is different color bell paper. This is the population. You have to get the data. Example, element 4. So elements, I told you the like a property, like a male or female, but here there is no male or female. We can go for the color. Just think. And here, based on the color, there are 4 categories, 4 elements, right? So I have to take that samples. I want to check. Example, this is the population, these are the sample points. Now it is up to you. You can have 5 green, 5 red. Try to compare. Think. We can. Okay. Orange, 15 orange and 50 yellow, or maybe 60 yellow. You can compare. Example. But these will be represent to whom? This population. Green will represent to green. This is example. Okay, so sampling. Sampling is a technique, the way to get the data, to select the data, to select a group of belongs to the population. Okay, in this example, you cannot example in this whole group. Suppose if there is a paper which has a black color, will you select? Because only one black color paper, you will not select. This is the idea. You have to select which is in the majority. Okay, so to select the group belongs to the population, which should belongs to the population. And for example, if you are researching the opinion of the students in your university, you should survey sample of 100 students, which will represent to the all. Population versus sample. Population and sample. This is the population, this is the sample, right? It is an individual on whom researcher intended to generalize the findings. And this is the subset. Okay, now type of a sampling. There is a most popular sampling is a stratified random sampling, right? Stratified mean to say the group strata, right? You have to know when we should say strata, when should not say the strata. Next sampling will tell strata. Subgroup of a population divided based on a common properties, right? In this example, we selected the green one. Here, yellow, orange, or here, red, and here, yellow again, right? Yellow and orange, like little bit orange. So can you see these are depending on the color? So this is called the strata in stratified random sampling. So what we did, stratified random sampling. Okay, so elements are homogeneous with a single strata. It means to say in this group, all green colors, homogeneous in a single strata. Here, all strata are mutually different. Can you see all are different colors? It is a rule of this sampling. Okay, just I given you the example by pictures, so then understand well what is it actually. But in you have some numerical data, you have to focus on it, how we can do it, right? So we can select a randomly strata, better to use all. So better to use this strata or maybe this strata or this strata or this strata, right? So this is a stratified sampling. Cluster sampling is also most popular sampling, which will show the subgroup of a population divided based on a common feature. Again, now we should say cluster, not the strata. So in cluster, this group can have a different property. Previously, group has the same property, same color, but here cluster different. So this will represent to green group. It will represent to yellow. Just think, this is a cluster 1, cluster 2, cluster 3. When we will practice on the cluster algorithm in SPSS, you should keep in this mind. This is a clustering. So this is a cluster sampling. You can also do that. Okay, so theory, I have already written it here. You can check it. Cluster with the versus stratified sampling again. This is the difference. You please read it. I think if you understand the graph, you can easily make a difference here, right? What is the difference between cluster and stratified random sampling? Now let's go for the review. In this session, what we did in the starting, we tried to know each other and know about the content of the structure, program structure, exam theory, when we have to do. We also learned which tool we need, how to do, when to do, right? And after then, we just started our basic theory about the statistics, which covers descriptive statistics. We discuss central tendency. We discuss population and data samples. We also discuss mean, and these are the mean, mode, median, central tendency we discussed previously, right? And also when sometime mean is not working, we can go for the data range, interquartile range. You can also go for it. Dispersion also we discuss, and with the help of dispersions, we can go for the variance. We also discuss the variance. Thank you.